Hello everyone, welcome to Devincept. Today's video is about the different features of opencv library. You have already gone through opencv through our previous video and had a brief introduction about it. Today's video we will be teaching you that what are the things that we can achieve through the help of opencv library, what are the basic operations with it, and what techniques can we implement using opencv library and what are the applications. So let's start. Now firstly, what are the things that you can achieve using the help of opencv library? You can do image reading and writing. You can do video capture and storage. You can do various image processing tasks like filter, transform, etc. You can detect a particular feature in any video or any image through opencv. You can also identify specific items in any media files like films, videos, photographs, etc. Like people, their face, their eyes, the cars. We can also analyze a particular video by estimating the motion in which it is. We can remove the backdrop or the background of the video. We can also track items like moving cars in the video through opencv. Now, what is the history of opencv? opencv was initially developed in C++. In addition to it, there is also Python and Java extensions of it. opencv is also compatible with a variety of operating systems starting from Windows, Linux, OS X means Mac, and to a number of open source operating systems available. Now let's get into the basic operations with opencv. How do we get started with opencv? First is loading the image. So we have certain functions related to it. The most common which we have is cv2.imread. cv2.imread loads the image into the opencv sector, into the opencv library. cv2.imread, if we change the parameter a little bit, then it loads the image in its grayscale format. After loading the image, we can display those image by using the cv2.imread cv2.imshow. The image we had loaded will be displayed through this particular function. How can we resize the image? We can resize the image using the function cv2.resize, where we will put in parameters the object that we had created using cv2.imread, the object, and the required sizing parameters. So these are the basic functions that we need when we are importing anything into the opencv library and we're checking and we're getting it ready for our functions and for our work. Next, we move on to the various functions and use sets of opencv. What are the things that we can do with opencv? First is grayscaling. Grayscaling is the conversion of a picture from RGB, CYMK, HSV to other formats, shades of gray. In very simple terms, grayscaling is where all the color is being removed from the picture and we get a grayscaled, a picture which is done in the shades of black and white. What are the applications of grayscaling? There are a number of algorithms that can be tailored only with grayscale photos. For example, one of the widely used canny edge detection function, which we also have in the later part in the video, works only with grayscale images. Also, there is a dimensional reduction in grayscale images, which helps us in certain problems. Grayscaling can easily be achieved with the help of operation cv2.cvtcolor. Next, we come to the next technique is image translation. Now, what is the definition of image translation? Image translation represents the process of shifting an image from one location to another location. We have noted down the mathematical transformation matrix. To perform an opencv image translation technique, we must define an transformation matrix first. And the function which is used to implement image translation in opencv is cv2.wrapAffine. Now, what are the applications of image translation? Cropping of the image, shifting of the image, hiding any particular section of the image, or by animating the image using a loop. Next, we come to rotation. Rotation is defined as rotating an image by some angle, theta, where theta will represent how many degrees that we're rotating the image. OpenCV computes the affine matrix but does not preserve the ratio distance between them. Now, what is the syntax of rotating an image? cv2.cv rotate. The parameters that used are the original object of the imported image and the degree which we want to rotate. Here is a given example where we have rotated a particular image to 90 degrees. Next, we come to the applications of rotation. In which things do we need to rotate the image? We can rotate the image. It helps us to display the reflection of the image. And in case of rotation, it also helps when we have to align the image. Next, let's come to scaling. Scaling helps to resize the image. We have the function called cv2.resize of the opencv library cv2, which helps us to resize the image. Let's see what is the syntax of cv2.resize. We give the source image which we had imported from the user. We have the desired size of the image. We give also the scaling factors along the two axes x and y, and we can also give an interpolation where we can give certain defined parameters. Here you can see the code to resize an image is given, where we are giving the scale percentage to be resized. Once we're resizing horizontally and once we are resizing vertically. Scaling is also used in various problems, like when we have to fit one image into another image, and when we're using a large data set. So in that case, using the pictures would be very easier. Next, we come to cropping. Cropping is a technique which is being widely used by us through different softwares, through different methods. In OpenCV, cropping defines as the part of the image where we do not require and which is not falling into our region of interest. OpenCV images are open-numpy arrays. So basically, if we are considering OpenCV images as numpy arrays, cropping the image comes down to slicing those arrays. Here you can see a code where we have sliced down the arrays, providing the various parameters required, the start and end points, and we are building the slicing. Now, what are the applications of cropping? Cropping is mainly used for two things, where we can remove the unwanted part of the image, and that in turn results in to focus on the important parts of the image. Next, we come to edge detection. As we had said earlier, edge detection cv2.canny is an OpenCV library which really takes grayscale images as input. This method was first defined by John F. Canny, who was the first under whom this term is being coined. Canny edge is a widely known phenomenon and being used whenever we have to measure distance between the camera and a particular object, if we have to create a document scanner, if we have to detect any screen in an image, detection of road lanes, everywhere Canny edge detector is used as a pre-processing step. Next, we come to sharpening or filtering. The filter 2D operation of the OpenCV library is used to perform the sharpening of the image technique. Next, we come down to thresholding. Thresholding is the OpenCV technique that involves assigning pixel values in relation to a threshold value. The pixel values of the image are being altered using thresholding techniques. In this video will be showing you certain simple thresholding techniques like cv2.thresh binary. What is this case? If the pixel intensity exceeds the set threshold, set value to 255, set value to 0. Otherwise, when the pixel value exceeds the threshold given, it will be set to 255, and if it doesn't, it will be set to 0. The exact opposite is being done by cv2.thresh binary inverse, where if the set value crosses the threshold value, it is being set to 0, and if it doesn't crosses the threshold value, it will be set to 255. Next, we have the thresh truncated value, where if the pixel intensity value exceeds the given threshold value, it is truncated to that form of value. In this case, the threshold is set to have the same as the pixel value. The rest of the values stay the same. And lastly, we are having the thresh/20. For all pixels with an intensity less than the threshold value, the intensity is set to 0. Whenever any pixel value is less than the given threshold, the value of that pixel is set to 0. There is an opposite case also to this through cv.thresh_20_inverse, where if any intensity is more than the threshold value, intensity is set to 255. What are the applications of thresholding? Thresholding is widely used segmentation technique for distinguishing between foreground and background images. Background images can be made non-prominent through thresholding. And in computer vision, the technical thresholding is done on grayscale images. Lastly, we come to erosion and dilation. Morphological operations are a group of operations used to process image based on the shapes. cv2.erode dilutes the features of an image by eroding the boundaries of the foreground object. cv2.dilate enlarges the object surface in order to highlight specific features. To explain this, we have to imagine that cv2.erode, this function, it erodes the boundaries of the foreground images. It lowers this object surface area. In this way, the noise which is remaining in the boundaries, that is removed. And if any two images, two objects, or two media files are connected, it can detach them by creating a white space between them. In the contrary, dilation is used to highlight the specific features of the image. It enlarges the surface area, and if any image or any file has any broken parts, dilation is used to join them. Erosion and dilation are often used in harmony, where erosion reduces the noise of the image, while dilation brings it back, but the noise gets removed. So these were the various techniques that we can implement using opencv. We can detect the edge, we can create erosion, dilation phenomena, we can crop the image, we can scale the image, we can rotate the image to our own preferences, we can grayscale the image so that it can be used for a wider purpose. opencv is a widely used technique in sectors of computer vision, in sectors of machine learning. So tune into the next video where we will be discussing more about opencv and what more can be done through this library and its functions. Thank you.